For more than 40 years, the oil company's standard response to a major oil spill has remained the same: booms, skimmers, and dispersants. Booms and skimmers are eye candy, photogenic measures meant to reassure the public that something is being done. Skimmers typically remove about 3% of the oil, and booms, while they may appear to hold back the spill, don't actually do anything. Most of the time they end up strewn along tar-blackened beaches and tangled in salt marshes, adding to the destruction. But dispersants are the real problem. They break down floating oil and make it sink, which results in a dense underwater cloud 50 times more toxic than undiluted crude. Dispersants have been banned in 18 countries, but the oil companies keep using them for one simple reason: out of sight, out of mind. They see a major oil spill as a mere public relations problem. But there's a better way. After years of development and testing, the Mendes Equipment Company has patented a system for cleaning up floating oil in open water. Designed for simplicity, versatility, and ease of use, the MendesOilTrap is a hydrocarbon filtration system consisting of a rugged flow-through case containing a replaceable oil-absorbent cartridge called a cassette. The tank you see here is a portable scale model test tank built by Team Mendes for remote demonstration purposes. In tests, strings of oil traps consistently recovered more than 80% of the floating oil they encountered. The device is designed to be effective even in waves and currents, so that, unlike other methods, the recovery rate of the MendesOilTrap actually improves in turbulent conditions. And the utility of the technology is not limited to major oil spills. On average, more than 5 smaller loss of control accidents occur every year in the Gulf of Mexico alone. A stockpile of oil traps on the rigs would have an immediate and far more eco-friendly impact than the dispersants currently stockpiled there. The cassette can be removed easily by means of a hinged latched lid and taken to a trash for energy site for burning. The traps themselves can be linked together in a number of configurations, anchored across inlets or towed behind boats. They can be built to any size specification, tailored for use in fixed locations like harbors, marinas, shipping ports, and canals, or scaled down to filter small tributaries or street runoff in cities. They can even be equipped with marker beacons to prevent damage from boats. The applications are endless. Oil tankers, for instance, are already required to carry on board the equipment necessary to respond to a leak, and the oil trap could easily meet that need. Obviously, fully assembled oil traps would take up a lot of space, so to facilitate storage, transportation, and deployment, they're designed to be collapsible. The effectiveness, ruggedness, and versatility of the oil trap make it a far superior, far more eco-friendly answer to the out-of-sight, out-of-mind methods of booms and dispersants. All over the world, waterways are routinely contaminated by landfills, waste dumps, ruptured pipelines, industrial accidents, shipwrecks, and leaking vessels of all shapes and sizes. Oil trap technology is adaptable to all those situations. We can make the world a better, cleaner place. As with any new technology, there will be a need for training, preferably at a facility where responders can experience real-world open water situations. Our government spends tens of millions annually for the training of firefighters, yet allocates virtually nothing for oil spill response. The Deepwater Horizon disaster in the Gulf has taught us that an oil spill can have devastating and long-lasting ecological, economic, and human health consequences. But up to now, very few people are trained in spill response because there simply are no open water training facilities. During the government-supervised early testing of the oil trap, the Mendez team built lasting relationships with officials in Aruba who will allow them to establish an open water training facility, the first of its kind. Our oceans are already dying from overfishing, pollution, and climate change. Nearly a third of all coral reefs have already died, and another third are in danger. Recent studies show that over half of all fish populations are unable to reproduce fast enough to keep up with rampant overfishing. Dead zones are expanding, and acidity is now reaching levels not seen in 50 million years. The situation is critical, and something needs to be done now. One more major oil spill, compounded by millions of gallons of toxic chemicals and affecting a fishery the size of the Gulf of Mexico, could take us beyond the tipping point.